Hello and welcome at our little presentation about managing risk and quality with Scrum. I've made this presentation in the scope of, in the context of an ISO 9001 audit for Capgemini Belgium. My name is Gunther Verheyen and this presentation is actual to the date of 16th of November. So, what are we going to talk about? Let's first talk a bit about a small definition of Scrum. What do we understand with Scrum? What's not in Scrum? But let's not spend too much time on that. And then we will proceed with how we manage risk, how we manage quality, and I've added a little section about myself, the least important part of the presentation anyhow. So, about the definition of Scrum. I've recently found a very good definition by Ron Jeffrey, saying Scrum is about planning, building and demonstrating an increment of software, looking back at what happened and repeatedly improving this process. Scrum calls for specific meetings and rituals and even a couple of artifacts like burnout charts. Now, a bit more detail about the process of Scrum. It's not really a process, it's a tool, it's a framework, but okay. Let's make it easy and just call it a process for the time being. Scrum starts, Scrum is made for product development. So you've got a vision, you've got an idea, you want to build a certain product or project. You translate your vision into a product backlog. A product backlog, a list of features, tasks, whatever that needs to be done to build that product or that project. It starts with the sprint planning, during which the product owner, the representative of the business on your team, explains the highest priority items from the product backlog. In part 2, the team will discuss these, probably re-estimate them and commit to a subset of the product backlog, and that subset that we will call the sprint backlog. Then the sprint starts. A sprint usually lasts from 1 or 2 weeks to 4 weeks. I have a preference still for 4-week sprints because of my context of somewhat larger projects. So during the sprint, so the 30 days sprint, every day again the team meets in a daily scrum. A daily scrum is a short, powerful meeting of max time box to 15 minutes, and it serves only to share information amongst the team, not for management reporting, frightening people or whatever. During the sprint, the team applies to be defined engineering standards. Engineering standards will depend on technology, platform, technical framework, whatever. And at the end of a sprint, the team will do a sprint review, holding that the software that has been built during the sprint, during the iteration, will be demoed. And the team will afterwards look back at how they've performed, how they've worked, what they've done, what they should have done, and so on, to learn the day after the sprint retrospective, the new sprint planning starts. Short, I hope it's quite clear. I'm not going to go into artifacts or roles and so on, it's quite clear. Just mentioning, I've already mentioned the product owner and the team. The overall guardian, let's say, for the process is called the Scrum Master. Now, how about managing risk? Managing risk, how has it been done in traditional methods? Well, let's first talk about what is a traditional method. A traditional method is a method in which a number of tasks, activities are performed in large blocks, phases that are performed in a sequential way. So you get some sort of single pass waterfall model. I've tried to make a conceptual representation with the large phases, but even within the phases you've got a number of sub-activities or sub-phases and so on. But the blocks are done sequentially, meaning there are handovers, there are sign-offs, there are deliverables, and the next phase normally shouldn't or can't start if the previous phase hasn't been completed as expected. Now, what happens if you apply this model to a project or product development, you've got one large sort of big bang build during the test and integration phase somewhere. And up to that point, the risk will only pile up. You build up risk because you only create stuff on paper, you write code, but you don't get too much feedback. You get sign-offs, you get agreements by people, but that's it. So risk essentially builds up. Now, how is that done in an Agile or Scrum project? Let's look again at the same graph. In Agile and Scrum, we do exactly, not really exactly, but we do grosso modo the same tasks. We analyze, we build, we design, we code, we test, we integrate, and so on. But the major difference is that in Agile or Scrum, we do them every day again and again and again. Meaning, our phasing of a project is created by creating a number of time-boxed iterations. But in every iteration, even every day, we do all of the various tasks that we have to do. We don't do them sequentially, we do them as much as possible, even in parallel. This is done during a number of iterations, the one after another, until we've got a finished project or product. Now, as we do all of these tasks every sprint, every iteration again, by the end of every iteration, we've got a build, we've got a product, we've got a working product that we can demonstrate. So what happens to risk? Risk starts to decrease very soon. After the first couple of sprints, you've got feedback, you've got working software, you've got software that you've deployed that can even be put into production. So you manage the risk by delivering software frequently. Quality. What about quality? Quality can be defined in the first definition as working software, usable, deployed, production software. How is software being delivered, working software being delivered in a traditional method? We already know about the phasing, the tasks and so on, the sequential way of working, the one-time build moment, and how risk behaves. Now, working software, meaning delivering usable software, is delivering business value, because working software means that you can start generating a return on investment. As soon as you start, you will not create any working software. You work on paper during analysis, design and so on. You merely work on paper. You've got sign-offs, but that's it. There's nothing that you can taste, that you can feel, that you can use, that you can work with. You can only start working with the software at the time it is being built, and then you suddenly, just before that, when the coding starts to end, the unit testing starts, and then the real integration testing starts, you can start using the software and the value is being generated. So about 2/3 of the elapsed time of the project, there is no real value as in value like working software. Now in Agile and Scrum again, we know about the process, the various iterations during which all tasks are done again and again and again, and mostly done in parallel, so that by the end of every iteration we've got a build, we've got deployed software into production, with risk decreasing all the way. Now, how do we build up value? Well, we start building up value very fast, and we gather feedback, we gather change, we incorporate change, and users, end users, customers and so on can, even after the first iteration, already use a working product. So we just build up software. So big advantage, risk decreases soon and fast, and at the same time we build up value. We don't postpone anything until some future phase. That's a long way to go. And why can we do so? Because we've got a product owner, we've got someone from business involved, committed in the team, that makes sure that every day again the team builds the right software with the right features, the right details. We build and demonstrate that software, and we demand regularly, at least at the end of every sprint, the feedback of all stakeholders involved. That's how we assure quality following the definition of working software. Of course, there's also technical quality. It's not only about working software, usable software, it's about technical quality as well. We already know that we do all tasks on a daily basis, daily testing. Overall, we've got a number of very short feedback loops, feedback from business, feedback from testers. We test every day again. But on top of that, we define clear and concise engineering standards. Now I've added the most obvious ones. I've noted the most obvious ones, meaning that we try to work as much as possible in pairs, pair programming. Pair programming is not expensive, doesn't increase the cost or price of your project, but that's a bit too much detail to go into that right now. But a pair of programmers writes code upon a test-driven development method, meaning they write a unit test first and then they start writing code to make sure the test runs successfully. Next to that, all checked in code, so test first code, is checked in regularly and being read out by a continuous integration system who does deployment testing, technical testing, the test first testing, possibly even GUI testing via Selenium, for instance, all of the regression testing, and we do that every day again, multiple times a day even. Yeah. In the same, what we call quality loop, the second quality loop, we also include refactoring, active refactoring. Now, to be very sure, refactoring is not about debugging, it's about rewriting working code to make it simpler, better, clearer, avoid duplicate code, and so on. And as we work upon collective code ownership, all pairs have the right to rewrite working code and make it better. A deployable system from the continuous integration system is deployed on possibly a separate system even, where a functional tester, which I used to call the guide, but it's an agile tester who is full-time part of the team, will do functional testing every day again and again. So we've got unit tested code that's being deployed in an overall continuous integration system. So we've got regression testing, integration testing, and functional testing. And if necessary, if important, we can do performance testing, and we prefer to do it every night, overnight. So our quality loops are performed every day again and again. And that's how we assure technical quality in an agile or Scrum project. Now, my name is Gunther Verheyen. I work at Capgemini. I've been working there since March 2010, which isn't too long. But before that, I've been using extreme programming and Scrum in my projects full-time since 2003. For what it's worth, I did a certified Scrum Master course in 2004 with Ken Schwaber. I've created a Scrum Plus framework, so building upon Scrum for a framework specifically for fixed price projects. I represent Capgemini at the Agile Consortium in Belgium. I'm community leader. I've done the Professional Scrum Master certification with Scrum.org this year. Did level 1 and level 2. In the process of becoming hopefully a Professional Scrum Master trainer. I contribute to some blogs. I Twitter. I have a website. That's all I have to say right now. Thank you very much.